So I'm now joined by Ben Kaner from BT Global Services. Ben, nice to see you.
Hi.
So tell us exactly what you guys are doing regarding big data in the healthcare field, which I know your specialty. How are you using big data with regard to the healthcare field?
Well, BT has been providing services to the NHS for quite some time now, and one of the areas of that is we provide the infrastructure and capability that supports the secondary uses service, which is part of the spine capability. That handles the use of data for planning and many other services across the NHS, and therefore it's a very, very large and complex data store which is used for analytics. So it's more of a traditional data warehouse than big data in its modern sense. So more recently we've been using the experience that that has given us to deliver a set of analytics capabilities around things like what we call Open Insight, which brings together data from open data platforms from multiple sources in conjunction with a client's own data to actually give them the ability to do complex analytics on what they're intending, which supports their delivery of services to their patients.
Okay. As we know, healthcare, a very kind of complex area as an industry. What lessons do you think you can draw on for the telecom community at large with regard to what you've used big data for in the healthcare field they could sort of apply more widely to their operations?
I think there's two major lessons, and one is engineering is crucial. You have to understand the kind of data you're dealing with, because data is not a single big pile which you can do with what you will, particularly when in regards to sensitive or personal data. And so you have to engineer it properly, and you have to treat it with respect, and that's very, very important to us. And if you break that basic rule of treating it with respect, then, well, you won't be working for BT. Because it's important to us, our brand and our customers. They need to trust us. So engineering for security and control of that data is important. And that doesn't matter whether you're acting as it's data that you have created, in other words, you're the data controller for, under the Data Protection Act, or data which you're just processing on behalf of other people, which is where you're a data processor. There are different roles, but they're still critically important to get the engineering right. The second area is to get value from it, you have to understand the data. So it's not just the statistical analysis. There's a lot of stuff to do with understanding that with large amounts of data becomes large amounts of potentially spurious correlations. And with that becomes very important to understand the business that you're dealing with, not just the data itself.
So that whole idea around spurious correlation is a very interesting one. Obviously, telco has a huge amount of velocity and amount of data coming in. What are the sort of the key sort of points that I need to be aware of around that, as I said, data collection and correlation?
Well, I guess the simplest statement is if it's too good to be true, it probably is too good to be true. So when you're looking at correlations, don't react immediately. A correlation is essentially when you see a pattern in data. Often it's from visualization. You see a pattern because humans are good at recognizing patterns. So a lot of big data is about creating those visualizations. Once you've seen a pattern, you tend to automatically assume that pattern is real, and you start to create stories in your head as to why that pattern might be. Those stories are a hypothesis. That hypothesis needs testing. Now you need to be able to test that, not necessarily against the data which has just generated that correlation, but against another independent source of data, so you don't get artifacts within the data sources. This is standard scientific method, so hence probably the term data scientist. But if you're going to do it right, you need to understand that a hypothesis is always tentative, and it's a working hypothesis until proven otherwise. Now, if you're using it for marketing purposes, that may be enough. It can be disproved by the fact that marketing didn't work. If you're using it for other people's business, or particularly if you're using it for the clinical purposes, I'm afraid that it might be so is not enough for clinical decisions. So you have to be, again, very careful. You have to understand the business for which you're using the data. So that's the two things.
Okay. And who needs to be doing that? Should we be relying on people for those correlations? Should we be relying on technology for those correlations, or is it a mixture of the two?
It depends. In the end, the machines can learn that there is a correlation, but they cannot assign causality. So finding that two data items move in concert, as I pointed out in the presentation, all that shows is you move in concert. So that might be a spurious correlation. Now, so that can be machine learned, and if it sits with a model of reality that that underlies that correlation, maybe you can show that you can vary other factors with it, and that's machine learning in terms of adapting your network to unexpected data loads, those kinds of things. That can work, but what it can't do is generate, the machine learning cannot generate a theory or a model of what that correlation is in terms of causality. Like the link between lung cancer and smoking, it took ages to actually get the causal mechanisms. Once you've got the causal mechanisms, you can interpret lots of other data in that light. And that needs humans. At least I've never seen a machine that can do that, and if it did, I would probably call it Sir.
Thank you very much. Ben, very interesting.
Thank you.